Hey everyone, and welcome. Today we are diving deep into the entire Class 10 chapter on polynomials. We're going to break everything down into super simple, exam-focused pieces so you can absolutely crush it. So, to kick things off, I've got a little question for you. Picture this. A basketball player takes a shot. What does that perfect arc look like? Or think about the water shooting up from a fountain, that graceful curve it makes. Or even something huge, like a satellite orbiting the Earth. What on earth do all these things have in common? Well, the answer is polynomials. Yep, you heard that right. The very math we're about to tackle is the secret language that describes the world all around us, from the basketball court to outer space. So you see, this isn't just some random topic in your textbook. It's literally everywhere. So here's the game plan. We're going to start with the absolute basics. Then we'll go on a hunt for these things called zeros. After that, we'll see what they actually look like on a graph, uncover a super important link between zeros and coefficients, you'll need that for your exams, then we'll make polynomial division easy, and finally, we'll wrap it all up with a revision quest to make sure you've got it down. You ready? Let's jump right in. Okay, first things first, we've got to build a solid foundation. So what in the world are we even talking about when we use the word polynomial? Let's clear that up right now. At its heart, a polynomial is just a mix of variables, like x, and coefficients. Those are just the numbers sitting in front of the variables. But here's the one rule you absolutely have to remember. The most important part, non-negative integer exponents. It sounds complicated, but it's not. It's just a fancy way of saying that the power on your variable has to be a whole positive number. So powers like 2, 3, 5, or even 0 are fine, but no fractions and no negative numbers up there in the exponent. That's the key. Now, polynomials come in a few different flavors, and we actually name them based on their degree. And what's the degree? It's just the highest exponent you can find on the variable. Super simple. If the biggest power is 1, we call it a linear polynomial. If the highest power is a 2, it's a quadratic. And if it's a 3, you guessed it, it's a cubic. This degree is everything. It tells us so much about how the polynomial is going to behave. All right, with the basics under our belt, it's time to go on a little mission. We're going on a hunt for something called the zeros of a polynomial. So what exactly is a zero? Think of it like a magic key. It's a special number that when you plug it in for x in your polynomial, makes the whole entire expression equal to 0. That's it. It's the value of x that makes the polynomial vanish into a 0. And finding these zeros, it's a simple 3-step recipe. Step 1, grab your polynomial. Step 2, set the whole thing equal to 0. And step 3, solve that equation for x. Whatever answer you get for x, boom, that's your 0. That's the recipe. Follow it every single time and you'll nail it. Okay, so finding zeros with algebra is cool and all, but what do they actually look like? Let's stop thinking in symbols for a second and turn this whole idea into a picture we can actually see. And here it is. This is the big connection, the aha moment. When you draw the graph of a polynomial, the zeros are the exact spots where the line or curve crosses the horizontal x-axis. It's the point where the value of the polynomial is, well, 0. So if you can see the graph, you can literally just point and say, there's a 0, and there's a 0. Now let's compare the two main types you'll be working with. On one hand, you've got a linear polynomial. Remember, its degree is 1. Its graph is always a perfectly straight line. Now think about it. How many times can a straight line cross the x-axis? At most, once. So it has a maximum of 1, 0. Then you have the quadratic polynomial, degree 2. Its graph is that classic U shape we call a parabola. And a parabola can dip down and cross the x-axis up to 2 times. So it can have a maximum of 2 zeros. Okay, everyone, listen up. I need your full attention here because this section is an absolute goldmine for your exams. We're about to unlock a super powerful shortcut. The hidden relationship between a polynomial's zeros and its coefficients, the a, b, and c values. And here they are. These are the two formulas you cannot afford to forget. For any quadratic polynomial, if you add its two zeros together, we usually call them alpha and beta, the sum will always be equal to negative b over a. And if you multiply those same two zeros, the product is always c over a. I'm not kidding. Write these down, put them on a sticky note. You have to memorize them. Now, you know the single most common mistake people make? They forget that little minus sign in the sum of zeros formula. So I've got a silly little trick for you so you never forget it again. Just think of the phrase, negative boy over apple. Negative boy for negative b, over apple for a. It might sound a bit goofy, but trust me, it works. Let's put this into action right now. Take a look at 2x squared minus 8x plus 6. First, let's identify our guys. A is 2, b is negative 8, and c is 6. To find the sum, we use our formula negative b over a. So that becomes negative 8 over 2. The two negatives cancel each other out, so we have 8 divided by 2, which is 4. Easy. Now for the product, it's just c over a. That's 6 over 2, which gives us 3. See? Once you know the formulas, these problems are a piece of cake. All right, next up is a topic that sometimes makes people a little nervous, but I promise you we are going to make it super straightforward. Let's talk about polynomial division. Here's the secret. You already know this rule. Seriously, think back to elementary school. What is 7 divided by 2? It's 3 with a remainder of 1, right? You could write that as 7 equals 2 times 3 plus 1. Well, believe it or not, it is the exact same idea for polynomials. The thing you're dividing, the dividend, p of x, is equal to the thing you're dividing by, the divisor g of x, times the answer you get, the quotient q of x, plus whatever's left over, the remainder r of x. It's the same rule, just with some x's thrown in. And just like that, we have stormed through the entire core of this chapter. It's amazing how it all connects, right? So before I let you go, let's do a lightning-fast recap, and then it's your turn to prove you're a polynomial pro. Okay, let's lock in these key points. 1. The degree, that's just the biggest exponent you see. 2. The zeros, that's where the graph physically crosses the x-axis. 3. Those magic formulas for a quadratic, negative b over a and c over a, are your best friends for exams. And 4. The division algorithm is just the same old division rule you've known for years. Got it? Awesome. Okay, your turn. It's time to put what you've learned into practice. I want you to pause on the next couple of slides and really try to solve these questions on your own. This is where the learning really happens. Here are your first 2 challenges. For question 1, quick hint, don't get tricked. You need to expand that expression first before you can find the degree. For question 2, this is a classic. Just set up the formula for the sum, set it equal to the formula for the product, and then solve for k. You've got this. And for our final boss question, a little twist. This time, I'm giving you the zeros, and your mission is to work backward to find the polynomial. Think about how factors are related to zeros. Give it your best shot, and make sure to drop your answers for all the questions in the comments below. I can't wait to see what you come up with. Thanks for tuning in, and happy solving.